All right, so today we're looking at similar polygons, which would be two polygons whose corresponding angles are congruent and the lengths of the corresponding sides are proportional. So all the corresponding angles are congruent, so that part of them is exactly the same. What's different is the sides are proportional. In other words, if I make a ratio of one side of the big figure to one side of the small figure, and I do that for all the sides, all the corresponding sides, all those ratios I make should come out to be the same if the figures are truly similar. That's the reason we did proportions yesterday, so we could know how to deal with them today. All right, so trapezoid ABCD is similar to trapezoid PQRS. List all the pairs of congruent angles and write the ratios of the corresponding sides in a statement of proportionality. So if they're similar, we know that the corresponding angles have to be congruent. So that would mean that angle A would have to be congruent to which angle? In the small figure. Angle P. Angle B would have to be congruent to angle S. Angle C congruent to angle R, and angle D congruent to angle Q. All right. So all the corresponding angles match up, they're all congruent. And then to show the proportionality, we're going to take the sides and create ratios out of them. So side AB matches up with what side in the small one? PS. So AB over PS. And that ratio should be equal to the length of BC over which side? SR. And that would also be equal to the length of CD over RQ. I'll make sure that we put it in the same order. And then lastly, DA over QP. So if it's indeed similar, then when I actually put the lengths in for these spots in those ratios, all four of those ratios should simplify down to be the same values. And so with that, we want to decide whether these two figures are similar. One thing I left off, didn't speak about, up here where it said ABCD, it has this little squiggly line between PSRQ. That squiggly line right there represents similar, right? That's the symbol for similar, right? It's the little squiggly line like we use in congruent, but we don't have the equal sign because they're not exactly the same. So it's just the squiggle line saying they're related because they're similar. All right, so here we want to decide whether these figures are similar. If they are, we're going to write the similarity statement and find the scale factor. And your notes don't say find the scale factor. I added that in after I printed them. So first thing I want to do is start checking those ratios. So LM, which is 12, should match up with which side on the other triangle? Should go with RP, which is 9. And then LN, which is 18, would match up with RQ, which is 12. And then lastly, MN, which is 10.5, we go with PQ, which is 4. So if this is similar, then when we reduce those fractions, the reduced ratios should be the same. Right? So 12 over 9, 12 and 9 both divide by 3, right? So that would give us 4 over 3. 18 and 12 are both multiples of 6, so they both divide by 6, which is going to give us 3 over 2 and 10.5 over 4. That's really not going to reduce any at all. So when we look at those, we got 4/3, 3/2, 10.5 over 4. They don't appear to be the same, right? Which they're not. They appear to not be the same, and they are definitely not the same. And so since those are not equal to each other, that means that this is not similar. So then this pair of figures, so whether these figures are similar. If they are, write the similarity statement and find the scale factor. So start building our ratios. So AB, which is 33, goes with which side? DE, which is 11. And that would need to be equal to AC, which is 48, over 16. And that would be equal to BC, which is 39, over EF, which is 13. And then we go to simplify those. And 33 and 11. 11 is actually a factor of 33, right? 33 divided by 3. So that'll go to 3 over 1. And we're going to leave them as a fraction because we want it to stay a ratio. And then 48 over 16. 16 actually divides evenly into 48 3 times. 3 over 1. And then 39 over 13. 13 times 3 would be 39. So that one reduces to 3 over 1 as well. So since all 3 of those are the same, then we know that these are similar triangles. And then we can also, it wants us to make a similarity statement. So that just means to write it out that triangle ABC is similar to triangle DEF, putting a little wavy line in between the 2 figures. And the other part that it wants us to come up with is the scale factor. And for the scale factor, first off, we have to know what that means. And a scale factor is going to be the common reduced ratio. So that's that ratio that's in common between all the side lengths once we've reduced it. And so what is our common reduced ratio in this example? Three over 1, right? So, right, 3 over 1, 3 over 1, 3 over 1, so that's common. That's what they all have in common. And so we're going to write that as a scale factor, and usually when it asks for a scale factor, it's not written as a quotient, it's written with the colon. And also, in most cases, when they ask for a scale factor, we want to put the small side compared to the large side. So the small side value goes first. So our scale factor is going to be 1 to 3. In rare instances, you might have a problem that asks for you to give the scale factor large to small, but in most cases, it'll be small to large. So that scale factor of 1 to 3, what that's telling us is that for every 1 unit in the small triangle, we have 3 units in the big triangle. Or if you look at it in the opposite way, the big triangle sides are 3 times as large as the little triangles.